Hey there, folks! We've got some exciting news in the tech world about OpenAI's latest project. There's a buzz about a new advanced AI model, possibly a multimodal model, and it looks like the rumors are spot on. An article recently mentioned OpenAI collaborating with Microsoft to develop a super intelligent AI, and guess what? We're talking about the much anticipated GPT-5 here. This article, right from the Financial Times, is packed with information. It's a goldmine of details about GPT-5, some of which might have slipped past you earlier. So, I urge you to stick around as we dive into this. It's not just about today's news. There have been plenty of hints dropped about what GPT-5 entails, and we're going to unpack all of that for you. Let's zoom in on GPT-5. OpenAI's chief, Sam Altman, hasn't set a release date yet, but there's a lot of excitement building up. GPT-5's training will require heaps of data, a mix of publicly available information and exclusive data from various companies. This is crucial because for AI models like GPT-5, getting the rollout right is key. They're aiming for a smooth launch, knowing how much of a game changer this model could be. Now, talking about launch dates can be tricky. For instance, there's this robot, Neo, which OpenAI backs. It was supposed to launch last summer, and we're still waiting. This shows why precise timelines can be challenging in the world of AI. If you're curious about when GPT-5 might come out, we can look at GPT-4 for clues. It seemed to follow a 2-year cycle from data collection to release. We've got a video where we delve into this timeline in detail. Interestingly, Sam Altman, in a recent clip, gave some insights into when they might start working on GPT-5.
You, Mr. Altman, do you agree with that? Would you pause any further development for 6 months or longer?
So first of all, after we finished training GPT-4, we waited more than 6 months to deploy it. We are not currently training what will be GPT-5. We don't have plans to do it in the next 6 months. But I think the frame of the letter is wrong. What matters is...
But there's more to it. Predicting the exact capabilities of GPT-5 is tough, even for Altman. We know it will build upon the large language model, LLM base, and enhance image capabilities. The evolution from GPT-4 to GPT-5 is expected to be significant, adding more sophistication to the model. However, the specifics are still under wraps. Altman has previously hinted at integrating video capabilities in GPT-5, which opens up exciting possibilities.
Here, we can predictably say this much compute, this big of a neural network, this training data, this will be the capabilities of the model. Now, we can predict how it'll score on some tests. What we're really interested in, which gets to the latter part of your question, is can we predict the qualitative new things, just the new capabilities that didn't exist at all in GPT-4 that do exist in future versions like GPT-5. That seems important to figure out. But right now we can say, here's how we predict it'll do on this eval or this. There are a lot of things about coding that I think are a particularly great modality to train these models on. But that won't be, of course, the last thing we train on. I'm very excited to see what happens when we can really do video. Yeah. There's a lot of video content in the world. There's a lot of things that are, I think, much easier to learn with video than text. There's a huge debate in the field about whether a language model can get all the way to AGI. Can you represent everything that you need to know in language? Is language sufficient, or do you have to have video? I personally think it's a dumb question because it probably is possible, but the fastest way to get there, the easiest way to get there will be to have these other representations like video in these models as well. Again, like text is not the best for everything, even if it's capable of representing everything.
Video processing is a challenging area, but it's where GPT-5 could really shine. Current models, like GPT-4, can generate basic videos, but the goal is to push this further. The pace at which AI is advancing is incredible, with breakthroughs happening rapidly. At the end of a recent developer speech, Altman made a remark suggesting that what they're creating now will make their current offerings seem modest in comparison. This hints at the ambitious scope of GPT-5, and possibly towards their efforts in achieving artificial general intelligence, AGI. It's evident that OpenAI is going all in with GPT-5, as they're reportedly trying to attract top talent from Google and other tech giants with hefty offers. This move underlines the importance and potential impact of GPT-5 in the AI arena. GPT-5 is shaping up to be a powerhouse of technical innovation. The real game changer here is not just the size of the model, but the caliber of data it's trained on. Contrary to what you might think, bigger isn't always better when it comes to AI parameters. Recent studies are turning heads, showing that the effectiveness of data plays a more pivotal role than simply ramping up the parameter count. Let's delve into some eye-opening examples where smaller parameter counts, boosted by high-quality data, have outshone their larger counterparts. Consider this intriguing Microsoft paper titled, "Textbooks Are All You Need." It's a real eye-opener. The paper reveals a staggering fact. Switching from low to high-quality training data can triple the effectiveness of a large language model. This means a potential 3x jump in GPT-5's quality and responsiveness, even if the parameter count remains unchanged. The paper summarizes a landmark experiment. A large language model trained on 1.3 billion tokens, achieving comparable, and sometimes superior, results to models trained on up to 175 billion tokens, including GPT 3.5. This underscores a vital insight for GPT-5. It's not about the number of parameters, but the quality of data that truly counts. Moving on, there's another aspect likely to be integrated into GPT-5, springing from a fascinating OpenAI paper titled "Show Your Work." This paper explores how they amplified the raw power of GPT-4 simply by tweaking the training approach. They developed two reward models, one praising the final answer to a math problem and another commending intermediate reasoning steps. By rewarding logical reasoning, the model's success rate on a math test skyrocketed to 78.2%, almost doubling GPT-4's performance and outdoing models focused solely on correct answers. This approach, valuing the reasoning process as much as the end result, holds promise across various domains like calculus, chemistry, and physics. It highlights the significance of training models in alignment with human-endorsed thought processes, deemed safer than fixating only on correct outcomes. What does this mean for GPT-5? It implies a built-in step-by-step reasoning capability, potentially doubling its efficiency and enhancing the quality of its outputs. Then there's the groundbreaking Tree of Thoughts research, which revolutionized GPT-4's reasoning ability by an astounding 900%. This approach involved the model evaluating multiple decision pathways, assigning rankings to each, and pursuing the most logical outcome. If implemented in GPT-5, we could witness an unprecedented leap in its reasoning capacity. In the last part of this discussion, we're looking at something really important about AI, especially the new and advanced kinds like GPT-5. These AIs can read almost everything on the internet, which means they know a lot, including stuff about how to persuade or even manipulate people. This is a big deal because it shows that AI might be able to do things we haven't even thought of yet. Experts are a bit worried about this. They say that as AI gets bigger and learns more, what they call increasing in parameter size, it starts to do new things that no one expected. For example, an AI that couldn't do math suddenly starts to solve math problems, or it suddenly knows how to answer questions in a language it wasn't specifically taught. This is surprising because even the people who make AI can't always tell when or why these new skills will pop up. There's a really interesting example that shows just how different AI thinks from us. Someone trained a small AI to do simple addition, but when they looked closer, they found out the AI was doing it in a really complicated and unusual way. It was thinking about adding numbers like moving around in a circle, which is not at all how we humans would think about it. This is kind of scary because it shows that even when AI gives us the right answers, we don't really understand how it got there. It's thinking in ways that are totally different from us. So it's really important to make sure these AIs are safe and doing things the right way before they are used by everyone. Because if they think so differently, it might be risky or unpredictable what they will do next.